Hi, we are here with section 10.2 and 10.4, and I have them together because one talks about the hypothesis testing for population mean and the other is for hypothesis testing for population proportion. Now the process is same in both of them. The only difference is mainly for the formulas. For the z-score, calculating the z-score which will be our test statistic. And like in chapter 8, if you recall, I combined section 8.1 and 8.4 because they were a similar situation. So recall the general steps in a hypothesis test are: the first step is to state the null and the alternative hypothesis. Second is to determine which distribution to use for the test statistics. So to find the test statistics or to do the computations for the test statistics, what formula will we use? Well, at this moment you have only learned one, we have only studied one distribution, which is the normal distribution or standard normal distribution. But soon in the next section we will study, or you will be introduced with chi-square distribution. So in the exam, your test, part of your test will be like if you recognize the hypothesis testing questions, then you will have to understand which is for the chi-square distribution and in which you have to apply the normal distribution. Gather data and calculate the necessary sample statistics. So that is the next thing, that we have to find the sample statistics and then draw a conclusion and then interpret the decision. Now interpret the decision, it could be that the question might not ask you to interpret, but because word problems should be answered by last step for the answer or solution should be worded. It should be given in a worded form. So it's always good to interpret, write the interpretation in the end. So we want to see, okay, what is going to be the test statistic for a hypothesis test for population mean and sigma known. Now this is a condition that we have for applying the test statistics from the normal distribution that is here. Now there is a way to find or apply the hypothesis test for a population mean to distribution where sigma is not known. But we are not going to do that because that involves another formula for the test statistics, and which involve another distribution which you haven't studied in this class. So we are only going to do problems where sigma is known. So sigma will be given in the question because we need here to calculate our test statistics. I hope everyone understands what is x bar, what is mu, what is sigma, and what is n. Now the test statistic for the population proportion is again like a familiar formula. You have used this before. Again, remember, P is the population proportion, P hat is the sample proportion. What is the difference? Well, sample proportion often you have to calculate. Sometimes it is given, but most often the population proportion will be a given proportion. Also, in order to use this formula for the test statistics, we must also check these conditions. It's kind of a condition for applying the normal distribution to the population proportion. Yeah. So once we have done all the work and we are now about to make a decision, well, or conclusion, that can be just these two sentences. Okay? It can be these two sentences and not anything else, not anything that you might make up with words on your own. So don't use your own words here. These are exactly how you should remember them. You may write this all in words that reject the null hypotheses. So you can write it in words like this, or fail to reject the null hypothesis. So you can write it, or you can write it like this. Okay. Now there are two methods in the book explained, using the p-value and using the rejection region. Now we are going to concentrate on this, and in the final exam and in the online homework, it is expected that you use the p-value, because if you use this, there might be slight difference in the answer. So online definitely you want to not get points losed, and also in the exam, because as we said, we expect only that you know p-value method. And another reason is that this is the most commonly used in the hypothesis testing. Okay, so how do we do that, or how do we apply this method? First thing is, what is a p-value? So a p-value is the probability of obtaining a sample statistic as extreme or more extreme than the one observed in the data when the null hypothesis H0 is assumed to be true. So it means the more extreme or as extreme means how close the p-value is to the data, okay, to the number with which we will compare it. And based on that we will make a decision. So first thing, we try to understand what do we mean by a p-value and how do we calculate it. So in order to calculate the p-value, we have to look at one more thing, which is what you call them, the type of tests. Now I have told you before that there are basically three types of tests, where you can have a mu, for example, looking at the mean population mean hypothesis test for a population mean. So we can have mu equal to, for example, instead of value we can have a number like a, mu is equal to a, and this one will be mu is less than a. This will be mu is equal to a, and this will be HA, mu is greater than a, or a, and then here we can have not equal to a. So basically the null hypothesis is same in all three cases, but the alternative hypothesis is changing. So in the case of the less than, this is the called the left hand. So this is the left tail test. Left tail test. So if we have less than sign, then we call it left tail test. If it has a greater than sign, then we call it a right tail test. This one. And if we have a not equal to sign, then this is called the two tail test. Okay. So here they are shown in pictures. So in this case, when we have HA with mu greater than some value, then we have this situation. Yeah, we will have this situation that and then if we have less than, then we will have this situation. If we have not equal to, we will be in this situation. In other words, the p-value here, in this case, the p-value will be equal to the probability that Z is greater than A.